Let me do a quick 2-minute intro. Thank you for joining us today. Please save your questions for the end and mute yourself until the Q&A. For those of you who are first time with us and wonder who we are, Serverless Toronto started 7+ years ago as a meeting place for function as a service developers, but during COVID, we migrated to online format. And over time, we realized we could help businesses by working smarter, not by sprinting faster. And we started defining serverless not just as a tech stack, but as a pragmatic mindset, a way to focus on business value. And this broad definition of serverless allows us to explore various IT topics. So visit youtube.serverlesstoronto.org to check out all the educational events that we curated over the last 7 years. Many of them are still highly relevant, and we're constantly cooking something fresh for you. And in the next, in just 10 days, Dan Dobrin of Google will return to us. And as AI agents are coming, Dan is going to explain and demo A2A protocol, MCP protocol, and just announced ADK library for Java. And in July, another Manning author will visit us to talk about her book, AI Product Development. So this will be less hands-on session, but important for your future self, because with AI, you'll be coding less, but spending more time in various product roles. So get prepared for that shift and learn what PMs do and how you plus AI can help the business. And if you have a good idea for topics to cover or to want to present, mention it in the survey at bit.ly/SLSTO. We're always looking for new and altruistic ideas. Last but not least, a big thank you to Manning Publications for supporting us as a knowledge sponsor. And they generously donate a book title per meetup, but you have to fill in the survey bit.ly/SLSTO to qualify for the Manning book raffle. And we'll do it at the end of today's session. For those who don't win, Manning has provided 50% off coupon for just Use Postgres book and 45% off code for any of their digital products. So scan the barcode and enjoy the savings. And let me pass the mic to our guest. Denis, thank you for accepting my invitation to talk to us and walk us through your book. The floor is yours. Please take it away. Thank you.
Absolutely, and thanks, Daniel, for inviting me and actually encouraging to meet your community a little bit earlier, because the truth is that we started a conversation with Dylan probably several months ago, and the original plan was to gather with you folks once I finish writing the manuscript for my book. I still have to finish 3 chapters, so the job is not done. But then, ultimately we decided, like, why would we wait? Let's, just do this in May. It's kind of now or never. And what I want to start with actually, because what I heard from those who bought the book, who read it, like, because the book is already, even though the book is still in writing, it's available in a digital form. It's kind of the draft of the manuscript. It's not finalized yet, but those who kind of can stand and want to dive into the breadth and depth of Postgres capabilities can do this now. And many folks, said that, hey, like the title, it really sounds cool. It's for some of the people, it sounded marketish. For some of the people, it sounded straight to the point, especially to those who use Postgres for a long time. But generally speaking, the title is not something that is coined by me. So once you start using Postgres more actively, and once you get to know some of the people from the Postgres community, you will keep hearing that many of those community members would say, just use Postgres. Someone would come and ask, hey, can I just use, I have sometimes serious data. What database should I pick? And someone would say, you just use Postgres. Or kind of, I want to just handle, I need to deal with high performance workloads, and my company wants to use an open source database. What should I use? Just use Postgres. And there are many examples. But what we will discuss throughout this session is that My personal opinion, just use Postgres doesn't mean that you have to use Postgres for all of the possible use cases. That's not the only database that will replace all of them. No, but generally speaking, what the title suggested, that probably even if you don't use Postgres now, or if you are already using Postgres now or planning to use Postgres, at least get to know its capabilities. Because when we build, when we build application services and solutions, usually the less dependencies we have on different frameworks, libraries, and databases, usually it's better. And the story, let me share the screen, because I didn't, it's just blank screen, just titles, nothing specific yet. But the story, I want to start with the story, like why I decided to write this book. I think that half a year, like 1.5 years ago, I met my good friend for a quick lunch. We just had 30 minutes. And he kind of came, sweating. He just jumped off one of those meetings with his team, and he was kind of chewing his lunch as fast as he could and sharing with me a story. He was in charge of a migration of one of the solutions from the company's on-premise infrastructure to AWS. And for that solution, they used MongoDB. I have nothing against MongoDB, and by the way, I use Mongo for one of our projects right now. It's also a great database. And he says, like, Denis, like, yeah, we are moving, fast to AWS because that company is in AWS shop, but I cannot move Mongo. Why? I'm asking, because our infrastructure team says, like, yeah, we need to buy everything from AWS. But MongoDB, they're not going to sign a contract with Mongo, the company, with MongoDB is the company. And I'm telling you, right, like what's available to you? He says, like, okay, I can probably, switch to DocumentDB of AWS that supports the Mongo query layer. But the infrastructure team of the company doesn't want to maintain it. They don't want to support this in production. What options do I have? And I'm asking, like, what do they support in production if you move your application there? He says, like, they support Amazon RDS, they support Amazon Aurora. And I go, like, okay, then why do you need MongoDB? What's the primary reason? He says, like, just our application is written in JavaScript, and JSON is the main object type, like whatever goes with the application, that's the exchange data format. And this is actually what we store in our database. It's super convenient. And I go, like, but why don't you use Postgres? He goes, like, what do you mean? Because Postgres supports JSON natively. JSON is the first-class citizen in Postgres. That's the part of the core Postgres. And he says, no, you're kidding me. Like, Postgres is just a relational database. I'm saying, like, I'm not kidding you. Just check it out. Eventually, and after that moment, something clicked in my head, because I've already, those days I worked with another company. Its name is Yugabyte. They are building a distributed Postgres. But I was, spending actively most of my time working with the core Postgres community. And I kind of I realized something, like, he was not the first person who didn't know extended Postgres capabilities. And I had a plan in my head. I wanted probably to create a course on YouTube or write a book. And I was like, yeah, if my friend, a principal, senior level architect and engineer, doesn't know about Postgres capabilities, then how many other people do not realize what the database is capable of? And after that, it's by coincidence, it happened that Jonathan, he is one of the acquisition editors from Manning, reached out to me. He wanted me to write a book about GenAI. I said, like, yeah, that would be a wonderful topic, but like, if I start writing about this GenAI, then by the time we release my book about GenAI, it might be no longer needed to anyone, because the landscape is developing so fast. But I came with a counteroffer, and the counteroffer was this book, Just Use Postgres. And eventually, yeah, we signed the contract, and right now it's like I'm no longer happy, because it's just it's a very hard work. Anyway, but why Postgres is becoming so popular? If you know, like, there is a special website called DB Engines. Let me show you here. So what's great about that website is it comes with a rank. As of now, I think it ranks how many, like 424 database systems officially tracked by this website. And it tracks the popularity. It tracks the popularity of databases, various databases, not, just Oracle, MySQL, Postgres, a bunch of other databases. And the popularity is measured by different, ways. For instance, the number of questions on Stack Overflow, how frequently a database is mentioned in discussions on Twitter and other social media channels, etc., etc. If you're interested, you can explore. But what's cool about this graph, if you take a look, this is what you can do with the website. You can go and create a chart to compare the popularity across several databases, and you can see that throughout the last, I would say, like 10 years, Postgres, keeps rising, steadily, step by step, it goes up. The other databases, like some of, not all the databases, absolutely, but at least Oracle, MySQL, we use all of them. They either stagnate, their growth is, just stagnant, or they just go a little bit low. And the growth of Postgres is basically, I would say that there are three reasons that explain the Postgres growing popularity. The first one is this is a true open source project that is governed by a true open source community. I worked with the Apache Foundation for many years, and there are many Apache projects such as Apache Kafka, Apache Hadoop, right, Apache Spark. But usually when you look at those projects, you would see that one of the company would have more votes because that company might hire many contributors to an Apache project. And that company sometimes can, just rule the community and rule the destiny of the project. Even though there are different measures within the Apache Software Foundation that can, prevent this from happening. But that sometimes can take place. With the Postgres community, that's not the case. With the Postgres community, there are the core community members who contribute to the core engine. And when you have a community, someone who is recognized as a committer within the Postgres community, also the community checks like what company do we work for? Because big cloud providers like AWS, Microsoft, Google, their employees, they contribute to Postgres. And the community makes sure that whenever they will be selecting the next committer, there will be no more committers from the AWS side, so that AWS cannot take control of the project. So this is this approach works for a while, and the database is fully open. Whatever is there, it's permissive. That AWS, that Microsoft and companies, large and small, they can sell Postgres, right? You can, create some new feature. You can create, you can build a solution on top of Postgres. And you don't need to pay back to Postgres, right? Postgres is fully open source. The second thing is that Postgres is enterprise ready. Because the community releases major versions of Postgres every year. But even with these, quite frequent release cycles of a major version, they pay a lot of attention to the quality. If, let's say, someone has been working on a feature, like big feature, and that feature is usually like big features, obviously split into several, smaller tasks. And let's say that you're given a year. Let's say like if you can complete all those tasks within a year, and if they're over decent quality, and if you pass all the reviews of your fellow committers and contributors, then you will be able just to release your feature in the next major version. If you just don't make, if it's not possible, if you just don't have enough time, then guess what? Wait the next year. That's how it runs. But that also helps, just to keep the quality of the product very high. And I heard many times that those companies who would like to find an alternative to Oracle, and we know that Oracle is also one of the best, right, relational databases, one of the best qualities, reliability, etc. But you need to pay a lot. And those companies who don't want to pay to Oracle the fees, they're searching for alternatives. And many say like, yeah, we selected Postgres, and surprisingly, Postgres is truly enterprise ready. And the third reason why that can explain that growing popularity of the database is Postgres is extendable or extensible by design. So Postgres, as the project was founded back in the days in Berkeley, in the Berkeley University, California, and Mike Stonebreaker, one of the database veterans, he was also one of the founding fathers for the Postgres back in the day in the university. He set in stone that Postgres had to be extensible by design. That's why, like, when those community members who create extensions, they can within the core database engine, there are different hooks or like places in the code of Postgres that you can plug in your logic so that you can intercept, query execution of your queries, so that you can intercept various metrics, and that allows you to create extensions. You can introduce your own data types. Today, I will quickly show you a demo for the Postgres PGVector extension, and this extension enables us to use Postgres for generative AI workloads. And that extension, what it did, it introduced special data types, like vector data type, that allows you to store those embeddings, like arrays of floating numbers. And it introduced special operators and functions that you can use for the nearest neighbor search, approximate nearest neighbor search, etc. Those operations. And that was possible because Postgres, the core Postgres, allows to add new data types. It allows to introduce new index types. And you don't need to fork Postgres for that, right? You don't need to create your own version of Postgres for that. Let me see what else. What Postgres usually offers. If you go back to the story I started with, when I had the lunch with my friend, who did not realize that Postgres supports the JSON data type and like different features for JSON natively. That perception was clearer to me, because same as me, my friend started using, like, the first time I and my friend used Postgres was probably like 15 years ago. Back in the days we worked together, we were building some like social media network. That was the time when Facebook was released, and many companies wanted to create their Facebook killer. So we were building our version of Facebook. We used Postgres. Those days, Postgres was not that well known. MySQL was the king of open source databases, relational databases. And we knew Postgres as a relational database, and whether we like it or not. And Postgres is a wonderful relational database. And as a relational database, it's like the primary language the database speaks is SQL. Also, abilities required for data integrity, such as primary keys, foreign keys, different check constraints, whatever is necessary to make sure the data is in the consistent state within the database. And you kind of, how you build for your application, you just create tables, right? You populate with the data, and then if you need to join data between stored in different tables, you use joins. Some people hate, hearing about joins. I like joins. But this is what relational databases offer. Then functions, triggers, views, there's so much more that you can find in Postgres as a relational database. But also what's interesting, that also Postgres offers some of their core capabilities that go beyond relational, and the first one is the JSON. It's possible just to create a JavaScript, Java, or whatever application and store data in the JSON format. There is a special data type, and there are special functions and operators and indexes that would allow you to work with the JSON data efficiently. Also, full text search is available in the core Postgres. It's not an extension. You can, if you, that was in, I think that right now, probably these days, many more people would be using GenAI, because I see also like GenAI as a smarter version of full text search, but still full text search is in Postgres, in the core Postgres. However, many more capabilities are coming from the ecosystem of extensions, and under the broader ecosystem, I assume some of the derived solutions, some of the databases that reuse Postgres source code, such as YugabyteDB or CockroachDB, AlloyDB of Google, they use also Postgres source code. But as for the extensions, today we will take a look at the PGVector. Also in my book, I talk about, it's not possible to cover all of the extensions. There are literally dozens, not dozens, I would even say like hundreds of extensions out there. Some of the extensions, as popular as the core Postgres itself. For instance, geospatial, like PostGIS. Postgres stands, GIS is Geographic Information System. So there is an extension called PostGIS, and that can be used if you want to for geospatial workloads. Let's say different applications that use your that need to work with the data related to some of the some location on the Earth. Then we have timescale DB, which is one of the which allows us to use Postgres for time series data, and we have many more. So let's do this now. Let me see if we have any questions. Daniel, let's answer a few questions right now, I guess, and then I can jump and show something in practice. Because generally speaking, this is actually the quick intro, like why I decided, to work on this book. What was the reason? Why Postgres keeps growing, and what Postgres offers. Then I want to show you something in action, but I want also to make this interactive. Let's check if we have any questions.
So you prefer questions now, not at the end of the demo?
Yeah, yes, we can take the questions now. Let's see. I can take a break.
Not much in the chat. I was just okay. That's a comment. I don't see questions in the chat. Anybody has a burning question that cannot wait until the end?
It's okay. Yeah, folks, if you have any questions now, you just speak up. If not, I will carry on.
Keep going, and then we're going to have the end.
Question.
Oh, go ahead.
Sorry. I have a quick question. I don't know if it's something that can be answered quickly now. It's about PostgreVector, PGVector, because I've been dabbling quite a lot into Gen AI stuff, RAG applications, So I just wanted to ask, is PGVector like production ready, like serving like in an intranet of like, let's say 20,000 users in a large corporation?
Yeah, PGVector is undoubtedly is production ready. It was created actually by one of the big experts in AI and machine learning. His name is Andrew. And if you even go to, I don't know, like let's take those well-known enterprise-ready production databases like Amazon Aurora, right? Aurora. Amazon RDS, let's do just Amazon RDS, and we can write PGVector. Those databases, yeah, they support PGVector. This is how you do Gen AI if you use AWS, and the same for other cloud providers who support Postgres, and every cloud provider supports Postgres. Like PGVector is the extension you need to use with Postgres. And it's
compatible with all the models like OpenAI, Gemini. It's embedded.
Yeah. I will show you. Yeah, I will show you the demo. Yeah, it's better to see. Yeah, this is actually what I'm going to do next. Okay, so then let's. Okay, let's. Yeah, I think that Bill connected. Yeah, Bill. Yeah, thanks for going on mute. So let's do this. I run Postgres in Docker. So if we check my container LS, you'll see that I have Postgres with the PGVector extension running. It's possible.
You're not sharing. You're sharing the Amazon page.
Seriously?
No.
Okay, so let's probably I need to share my not application window. I want to share entire screen. How about now? You see it, right?
See the console, yeah.
Okay, cool. Let's make the font size a little bit bigger. So Postgres runs in my container, and I run it with the PGVector extension. It comes bundled. I don't need to install it separately. Let's connect to it. Docker exec Postgres. Now I have several containers with different extension. But generally, what this instruction does, it will connect to my container of Postgres with PGVector, and then once connected, I will use the PSQL tool of Postgres to open a connection to the database. I will be using the user Postgres. It's that simple. So I connect it. It's here. In the public schema, I don't have any relations, but I came prepared. If I execute d/dn command, it will list schemas that are available in my database. I have this schema named OMDB. It stands for the Open Media. I don't remember. It's Open Media Database. So those of you who would like, to experiment with different movie titles, movie descriptions, there is a wonderful community project. It's fully open source. You can use them. I use this database, the database with many movies, thousands of movies in the book. You just need to kind of give some gratitude to the community and mention them. But they did a great job. So we are going to use a subset, a small chunk of this database. It's stored in my OMDB schema. We can do this. We can take a look at the tables that I have there. Yeah, I have two. Let's do this. I will use a special instruction that will set the search path to OMDB. I don't want to type the schema name every time I execute a query. So I have these two tables, movies and phrases dictionary. I will explain why I have the second. If you take a look at the movies, so generally it's very simple. Every movie has an ID, name, description. Then I have the movie embedding. So this is of the PGVector type. It stores an array of floating number, and every array has 1024 dimensions. And I will show you later, a little bit later, I will run several samples in the Jupyter notebooks. I will show you the model that I utilized. But generally, I have some data, some information about the movie, like revenue, budget, etc. Let's take a look at one of the movies. Let's do select name, description. From movie, let's do two movies. Movies, right? It needs to be movies. Okay, cool. And let's do extended screen mode so that it fits into my console. So those were two random movies: Jurassic Park, some description. And generally, what we have in this movie embedding column, if we execute it, let's do it this way: movie embedding column. You see this, huge array of floating point number that was pre-generated, and how it was generated. What I was taking in my sample application, I just took, the title of the movie. I took the description of the movie. I fed this information to an embedding model, an open source embedding model. I used, locally Olama, but you can use any GPT model, or you can use not GPT models. You can use embedding models from OpenAI. You can use embedding models from other LLM providers. But generally, that's very simple. And once you have this, what it gives to us, we can work with this data. We can work with this, some numbers that make sense to embedding models, but have no sense to us humans. How do we work with these numbers in Postgres? Postgres comes with extensions, and as I already said, this instance of Postgres is shipped with the PGVector extension. If my memory doesn't fail me, let me do this select star from PG extensions. There is a special function. Yeah, I have two extensions installed and enabled for my database. One of them is PGSQL. This is enabled always by default. It's used by those who create stored procedures using PGSQL language. And the second one is Vector. Kind of, I don't know why the name is Vector, why it's not PGVector, but this is the PGVector extension. And the GitHub repository for the PGVector is easy. Let's go here. So this is the extension that we are going to use. Also, before we dive into this extension, let me show you that Postgres is already shipped with some kind of pre-installed. There are dozens of extensions that are bundled with the core Postgres. Some of the extensions became so helpful, and that the core Postgres community ships them with the default Postgres distribution. And we can check those if we type this select star from PG. Yes, available extensions, hopefully. Yeah, let's do this. Let's disable the extended mode. So you can see that this is what we have in the default Postgres distribution, a bunch of different extensions for various tasks, such as pgcrypt if you want to have some cryptographic functions. What else interesting? The Bloom filters, if you want to have the Bloom access method. Then some of the extensions, we have this B3 index type, the default type in Postgres. We have GIN index, general inverted index in Postgres. And there is a special extension that allows us to use this both for some of the use cases. So a lot, many extensions, right? And many more can be installed, separately, such as PGVector. Now, let's run, as you remember, I said that I created I have another table named phrases dictionary. What we have in this table is, let's do this. What we have in this table is just a few columns. We have the phrase and we have the phrase embedding. So when I was writing the book, so the very first chapters, like I have a chapter about Postgres for GenAI. Obviously, otherwise it would be criminal to release a book without speaking about AI. And in the very beginning, I don't want the readers to depend on any LLM, to depend on any embedding model. I just wanted them to start Postgres with the PGVector and already explore how to use the vector similarity search. And to support that, I created the special phrases dictionary table. It comes with some of the phrases that we can, that we can experiment with without having any LLM or embedding model running nearby. Let's take a look. Phrases. So it's like 4 phrases. May the Force be with you, a movie about a Jedi who fights against the dark side, and a couple of more. Okay. And for every phrase, if we do this, I generated an embedding, vectorized representation. Let's just show one of them, limit 1. Now we need to do extended mode for the screen. Oops. So again, this is the embedding for the phrase, may the Force be with you. So this is how it looks like, okay? And now, even, we have this table with the movies. So what happens if we try to find movies that are related to the phrase, may the Force be with you? All of us know, right, what those movies are. But generally, this is what makes those GenAI applications so popular. You can just, type something in, and then magically your application responds with something that is meaningful. So what we can do, let's do this. Let's find the name of the movies from the movies where movie embedding, we have this movie embedding column, you remember, in the movies table. And then we will be using this cosine distance. I will explain it to you a little bit later, where there are distance between the movie embedding and get embedding function. This is a special function. I will also explain it to you how it works. May the Force be with you. How does it look like? May the Force be with you, where the distance is smaller than, let's do 0.5. Let's do order by, let's do this as well. Let's repeat one more time, and then I want to return only 3. So what's wrong? It says that no function matches the given name and arguments. Okay, cool. Get embedding, what's the name of that function? Get embedding does not exist. No function matches the given name and arguments. I think that I messed up somewhere. If the function name obviously needs to be this one. No function matches the given name and argument times. So how can we check? Because I don't want to waste our time. I will go to the GitHub project for the book. And if I scroll, get embedding. No, the function name is this, get embedding. Why don't you find it? It's the same, right? It's the same. It can be actually because of this, because I changed the search path to public. I think it cannot find the function. Okay, now it cannot find movies, but this is easier to fix. We just need to add this OMDB. Cool. Okay, so it found. So now let me break it down for you. So what happens here? We are selecting the name of the movie from their movies database, from the movies table. And what movies do I want? I want to find the movies which are close, which are related to the phrase "May the force be with you." And this operator is their cosine distance operator. What it does, it takes the embedding for every movie in my table and finds the distance for that embedding. It finds the distance between that embedding and the embedding for the following phrase. And this get embedding function, what it does, it just goes to that table with the phrases and finds the embedding for the following phrase. And I want to return only those movies which has the following distance. Like the distance is measured is in the range from 0 to 1. The closer to 0, the more related the movies are. And I just want to find, I will basically want to return all their movies which are basically like 50% close to the following phrase. And then I repeat this, I do this order by movie embedding. I calculate it one more time. Why? I just want to sort the result by this distance. And those movies that are closer to 0 are more relevant. That's why I want them to go first. Their order is ascending by default in Postgres. And once that is sorted, I want to do this limit 3. So this is what it returned. The first one is accurate. The second one is actually belongs to one of the Star Wars series. I didn't know that. And then you have this some other movie which is probably not unrelated. It also depends on your embedding model. I didn't use, the top-notch probably embedding model, but this is how it looks like. Sometimes you even need to give more text, right, when you generate those embeddings. Also, what's interesting, like this one is optional. If you don't want, to find any specific distance between your movie embedding and an embedding for the phrase, you can just, query all the movies from the movies table, sort them by the distance, and those who will be closer to this phrase will go first, and then you do limit 3, you will get the same output, okay? If you want to find, how can we improve this result? Because obviously this doesn't look like, I don't like this, the third output. Sometimes you can change your phrase so that helping, the database to find something that is more relevant for you. If you go back to the phrases, from phrases, OMDB phrases dictionary, but this time I don't want to have embedding. Let's just let me do something with the phrases. Let's do this one. That is a movie about a Jedi who fights against the dark side. This one is should return much more relevant result. So let's change it here. Changing the phrase. And this time, we are getting Star Wars Episode 6, then the Acolyte again. This is from the Star Wars series. And then you have episode 5. So in this case, you see like this is what we can do with Postgres. All I had to do is just to start Postgres with the PGVector extension. Then movies. Then in my movies table, I have this column, movie embedding of the vector type, and this type is provided by their PGVector extension. And it shows that I have every movie embedding has the following dimension. That's how many. That's the number of. That's the size of the array, pretty much. And then it provides you with different, operators such as the cosine distance. You have Euclidean distance, and it also has the index types. Right now, I might not have indexes, but we can check if it uses any index for this query. No, it does the sequential scan because I want to traverse through all of their records. But generally, this is what it has. Now, if you want to see how you would use it as a developer and to answer the earlier question of how to use Postgres with some of the embedding models, how to use with some of the large language models, let's do this. Let me jump to my zoom. Let me move it here. Let me go to Visual Studio Code, where I have a few Jupyter notebooks. So the first one, actually, I will just show you how the data for the database was generated. Okay, let me hide this one. Okay. I use Python, and as an embedding model, I still have LangChain. I have Ollama running on my machine. So this is the Ollama container. It's here. What happened next? I just used LangChain Ollama library for, let's do it this way, for Python. Then I was using this MXDAI embed large embedding model. It's also free. You don't need to pay a penny. You can use for your projects. Then I connected to Postgres. And then what I was doing, I was selecting every record from my OMDB movies table. And then in the cycle, for every record, I was executing this request. I was using the embedding model. And I was providing the text, combined text. The text was the name of the movie and the description of the movie. So basically, for every name and description of the movie, I generated an embedding, and then I wrote these changes back to the database. I was just updated a particular record in the table, setting the movie embedding column to the generated embedding. So this is how I pre-generated the data. No any rocket science. I had the data set from the OMDB with movie titles, descriptions, and then I just used this embedding model to calculate the embedding and write the embedding for every movie back to the database. And I used MXDAI embed large model, but folks, it's up to you. You can use embedding models from OpenAI. You can use embedding models from Anthropic or from any other LLM provider. So it's basically, it's not even, it's not like what's required from Postgres. Postgres, just needs to be capable of, storing embeddings in the database, and it obviously can. And then when you start, performing the vector similarity search, Postgres also can do that by relying on the PGVector extension. If to show you some samples, because I know that when you do this in the terminal, writing that SQL from scratch, it might be not that useful, because when we developers, build stuff, we usually use our favorite programming languages, or the languages that our employers require us to use. So what I want to demo in the following Jupyter notebook is just a sample, sample code. Again, this is for Python, but you can create it for any other programming language that will be connecting to my Postgres database and, running the vector similarity search over the data for the movies. So first, let's initialize this Jupyter notebook. I'm installing PsychoFiji2. This is the driver, Postgres driver for Python, and then I install LangChain Ollama framework. Next, let's initialize this embedding model object. And again, I will be using this same embedding model that I used for the embeddings generation for the movies data. It has to be the same, as we know. After that, I connect to Postgres. Postgres runs on my localhost and Docker, and I just connect through the localhost, the port number, database name, user, and password. Connection is open. And now we have this phrase object, a variable, where I can type any text that I would like to search for. Then once the phrase is typed in, we will use this connection. We will open cursor. We will connect to the database. Then for the phrase, I will generate an embedding for the phrase, and after that, I will execute this select request. This is how simple it is on the application layer. I'm just selecting the ID of the movie, name, description from the IMDb movies, and I just need to order by. I want to find all the movies that are close to their provided embedding for my phrase, and then I order them in the ascending order, meaning those which are most relevant, most related to my phrase, they will go first in the result, and I am returning the first three. So this is how it works. And after that, I'm closing this cursor, freeing up resources, and I'm typing the result. Let's run for this phrase. So for the phrase, a team of superheroes come together to save the world, Incredibles, X-Men heroes. We can try anything we want. We can do the same, may the force be with you. Let's run it. Yeah, it shows the same result. Or let's say some popular movie about a park and dinosaurs. Have to find it. Yeah, Jurassic Park, everyone knows. So pretty much this is how it works. And with this simple example, what I wanted to show you is that Postgres just provides you the foundation. It stores your data. When we take this movies database as an example, it stores the data for the movies, titles, descriptions, budgets, revenues, etc. And also it stores the embedding for the movie description, which allows us to use Postgres as a vector database. So if you want to create a GenAI app that wants to query this data in the smart way, it's possible to do. All you need to do is just to spin up Postgres with the PGVector extension. You need to generate embeddings for your, let's say, data, such as in case of the movies, it was title and description, and then create your application using your favorite language. So every major programming language supports driver for the Postgres. And if you use JavaScript or Python, you can use LangChain framework. If you use Java, you can use Spring AI. If you use any other programming language, all of them, have some of the frameworks that provide foundational capabilities for GenAI, and then just interconnect them with your Postgres database. Having said that, hopefully sorry about that, it took longer than 30 minutes of the time, but by showing that, the final question, does it mean that you need to use Postgres for everything as a summary? I would say that no, you should not. My point is that even if you take a look at the title, just use Postgres doesn't mean that that's the only database that replaces all the other databases. That's not true. But what I want to show with the book is that I want you as a developer, database administrator, or some other technologists to know that the Postgres capabilities. Just know the capabilities and consider Postgres as one of the options for your project. Because let's say you already use Postgres as a relational database, and then suddenly one of your teams wants to store JSON data because it's convenient, because they need this. You don't need to just spin up another database just for the JSON. Postgres has it. Or if you just need to use GenAI, probably Postgres will be enough. And the point here is that if like there is another reason, probably like you want to use Mongo because Mongo probably supports something that Postgres doesn't have, but at least do this POC, compare Postgres to Mongo, because probably it's in some of the cases Postgres might be enough, in some of the cases it might not be enough, and then you will go forward with Mongo. But at least you will know that there are several options, and you also will consider Postgres as one of the options. And as Daniel showed, if you want to start reading the book while it's still in progress, here is a discount for you. Just take a screenshot and feel free to provide feedback. So I'm done, and handing over the mic back to you, Daniel.
Thank you so much. You see, like because you were busy, we were thinking just about 30-minute walkthrough, but this question made a pivot deep dive into the demo. So I really liked it and hope the audience will appreciate. And you can read the rest in the book. So let's stay a little bit longer after 7 because now you're here with us. There is one question in the chat I see, and I wanted to ask you the same one. Richard asks. Can Postgres work as graph database? So let's that be the opening question.
Yeah, my response would be that Postgres has an extension called. It's actually that extension belongs to the Apache Software Foundation. It should be Apache. It should be Apache AGE, I guess. No. Oh yeah, I was right. So this is the extension that provides graph support for Postgres. So it's there, but I don't have any. I cannot share my personal experience because I didn't have any opportunity to use it, and I do not cover this extension in the book because the book still kind of has to be small enough. When I was talking to the publisher, they kind of planted the right seed in my head because originally I wanted to create a much larger book, but they said like, Denis, ideally the book should have no more than 350 pages. And I'm asking like, why? Because if the book is thicker, then it will, just collect dust on the bookshelf. We want the book, we want people to read the book. That's why the shorter the better. That's why we spent almost 2 months trying to finalize the table of content, the title, the sections, but eventually we didn't have a room for the graph databases. So explore please this one. And also what I read, right now I've been working on the chapter about Postgres for geospatial data, and I stumbled upon the following extension. It's called PG routing. And PG routing is this is another extension of Postgres that complements PostGIS. It allows you to kind of calculate driving directions if you're building some, navigation system. And let me show it to you. And people say that PG routing can also be used for the graph workloads. How did I find this? Let me Google PG routing graph. Yeah, like Supabase. These folks, there is a nice article. They talk how you can use PG routing if you want to use Postgres as a graph database. So like at least 2 options. So this is what I can quickly offer to you.
That's awesome. But this leads to related questions. So there are so many plugins, and there is a saying like a jack of all trades, a master of none. Are you aware of something that we shouldn't use Postgres that warn us like upfront? Like it has a plugin, but do not go there.
I would say that obviously every plugin, every extension, it's like you need to check how mature a plugin or extension is, whether the plugin has a core team that consistently supports it. For instance, when it comes to PGVector or PostGIS or Timescale DB, those extensions are as popular as the Postgres itself. I mean, like it's like the match for Postgres that was born in heaven. Some of the extensions, can be still in their early days, and if you're ready to take a risk, you take a risk, right? But my point, someone even was asking me like, hey, Denis, okay, you talk about this time series, Gen AI and relational database, but what's about analytics? Because ultimately Postgres was created for transactional workloads. And I was always, let's say, a little bit doubtful that Postgres is kind of good enough for analytical workloads. But the time has changed even my perception. Right now, you can find, many extensions that enable Postgres for analytical workloads, such as, this DuckDB. DuckDB is probably the rock star in the analytical world these days. And DuckDB has Postgres extension that allows you to just use 2 databases together in an efficient way. So that extension actually was released when not long time ago. But my point is that even if you kind of start using this extension, it does not mean that this extension turns, Postgres in a full-fledged analytical database. Because I believe that even with this extension or any other kind of, options, something might be missing, because there might be some true analytical databases that do so much more, right? And you still might need to use them because the Postgres, like PGDuckDB extension, doesn't support this for Postgres. But this is also the point of the book I'm trying to make. Let's say that you already use Postgres, and now you've got, some workload, some team comes to you and says, like, all right, folks, we just need to enable these analytical, queries of our Postgres database. What can we do? And you can tell them, all right, guys, just go to and use this analytical database. Let it be ClickHouse, right? Or let it be, Amazon Redshift. Use it. Or the option can be, let's say, what exactly do you need? You take a look at their queries and you see that probably you don't need to have any other database. PGDuckDB can be enough. So, which means that sometimes what is provided by the extension can be more than enough that you need. If you need something that goes beyond what an extension provides, then go ahead and select a specialized database.
Thank you. Thank you for the answer. I promise last question, Corey. I see your hand raised. So you did mention Supabase. Like, I'm guilty of not using Postgres for years because I'm paying nothing for the website, and then suddenly I have $15 a month, like for Postgres database. So can you please elaborate to this community serverless options for Postgres?
So as for the serverless options, I would say that Supabase is very well known, and the beauty of Supabase is that Postgres is in the core of their offering. Whenever you create a project in Supabase, it's gonna use Postgres. All your data is gonna be in that database. However, they are not just Postgres providers. They provide you the sort of an application stack for your serverless applications. For instance, if you want to have authentications, you want to have edge functions, you also have some real-time, you want to have some S3 compatible storage or RESTful APIs. This is what you're getting in addition to that. So this is sort of an application platform that is powered by Postgres as well. Historically, one of the first true serverless Postgres databases was Amazon Aurora serverless. And what Amazon did, Amazon Aurora serverless, it took Postgres, the upper level of Postgres, the query layer. They keep using it so that all your applications that were created for their vanilla Postgres, original one, they will be working with Amazon Aurora serverless. But then they changed their storage layer, and they use their own storage layer that allows you just to scale easily, that allows you to quickly start your application instances, shut down them, and scale as you go. After Amazon Aurora serverless was getting some traction, in the Postgres community, we've got another database, and this database is called Neon. And Neon is basically the serverless Postgres. So I sometimes find them quite, similar. They look a little bit, similar to Supabase, even like if you check the style of their website. But Neon is 100% focused on Postgres. It's like this serverless Postgres. That's their bread and butter. In the case of Supabase, Postgres plus additional, building blocks that your application needs. However, what Neon, since Neon is 100% focused on Postgres, they also re-engineered their storage layer. Initially, the initial offering was on AWS. And, as far as I know, Neon will be starting much, much faster than Amazon Aurora serverless. So they have their kind of own cool solution. And now they are also expanding and providing, I guess, some offerings on Microsoft Azure as well. So this company became so successful that I think that a couple of weeks ago, you might have seen an announcement saying that Databricks is acquiring Neon. So this is what's happening. But these are pretty much what we have in the Postgres serverless community. And when it comes to Postgres serverless, what's important to know, this is an example of derived Postgres solutions. companies like Neon or companies like AWS, they took the Postgres source code, they kept pretty much their query layer untouched, but they re-engineered the storage layer of Postgres, making it serverless.
I had no clue I'm going to get so excited about such a retro topic of Postgres. Last question. So you did mention it's more a comment, really. You mentioned analytical workloads and you mentioned Amazon offering. So I read, but it has to be fact-checked, that AlloyDB by Google does offer analytical workload that's optimized for it. So I don't know if anybody's here using it, but that's my comment.
Yeah, AlloyDB, actually, I think that my opinion that Amazon was the first, like Amazon Aurora was the first, like we have Amazon Aurora, just Amazon Aurora, but when you would provision instances, EC2 instances of certain capacity, and those will be running always, it's not serverless, but then Amazon introduced serverless. And AWS was the pioneer in this landscape. After seeing the success of AWS, Google also decided, that they want to get the chunk of the pie, and they introduced AlloyDB. But AlloyDB was not, just a replica of Amazon Aurora. It's like Amazon Aurora that also can support analytics. So they also keep their query layer of Postgres, I believe, untouched, so that your applications created for Postgres can work without any changes on AlloyDB. But also in their storage layer, they supported their analytical workloads. They support columns, as far as I remember.
But they're not serverless, so it costs money. That's why I never played with it.
Yeah, they might not be serverless, but what they actually did, they can be run on-prem.
On-prem, yes, that's offering.
Yeah,
So Corey, you've been patiently waiting for a long time. I apologize. I really didn't expect to enjoy this so much.
I hear you there. Can you hear me right now?
Yeah.
Okay, I gotta lower my hand. All right. Yeah. So I had a couple questions here. I'm actually trying to build what they call a load board website for the trucking industry, and it requires real-time data on their board. Basically, what it is it has a bunch. It's like a job board for trucking companies, and so it lists in there, about 50 columns of data per job. It'll have credit scores and credit ratings as well, not only including like their contact information, the company information as well, and also include mapping using a mapping software of some kind as well, because most trucks need a direction or need to see where the loads are being picked up and delivered to, and so it's a really I think it's a high processing kind of website based on the fact that you need mapping software, thousands of users, a database table that goes with it, and probably thousands of postings as well in the table with 50 to 80 columns of data per posting. And there's thousands of users querying each posting and looking at each one. So I'm trying to figure out some ideas here on what's possible with I'm trying to basically, I've been quoted here $30,000 a month to run a website like this, and I'm like, this is out of this world kind of money for me. The people that I'm working with on this thing are willing to spend about that much on building the website, but when it comes to like trying to run it there, I think we're trying to find a budget friendly idea for it, and I wasn't even too sure. Like we haven't even got to the serve, but we're open to any option here. But generally speaking, kind of seeing that the Google Maps API is going to be about, if we computed it out, it's like $10,000 to $30,000. If we use AWS, it's like the same, but in compute power. And we're starting to consider local server stuff here and build our own server for a few $1,000s and put it in our own data center, because we have a guy here in Toronto area for like 150 to 100, $200 a month, and we can put a 250 gigs of RAM in that server, and 40 processors, and however many terabytes of storage and so on. And that's what I'm starting to lean towards, but I'm not too sure because I'm not super experienced on the local stuff, and everybody seems to tell me don't do that, do AWS, do DigitalOcean, you know, for this kind of setup here. And you talked a lot about like even PG router and all that. I kind of built out something like that 2 weeks ago. On my own little local computer or whatever there. So it's kind of neat actually that you're talking about geospatial databases and stuff like that. But to tell you the truth, there I'm a new software developer, been in it for a year,
Yeah.
and I'm a vibe coder. If you've heard the term lately,
Yeah.
it's like the guy that learned through AI, and been able to do a lot of stuff that's shocking the world so far. If you look at my stuff that I built here in the last, I don't know, 4 months or whatever there, I built AI software, and mapping software is the one big thing right now because I got this big job on my hands. I'm trying to figure out what the solution is, and if you have any advice for me on my approaches, because basically we're trying to keep that pricing of that 1,000 user website down to about $100 to $250 a month is what I'd like to see a budget for that thing at 1,000 users. And then after that, we could start slowly increasing that budget per month. But I don't want to spend $10,000 to $30,000 on a website like that. I think that's ridiculous, and I think it's kind of inappropriate
Yeah, that's,
from
yeah,
being
since
an owner of a small business.
yeah, my take would be that since we've been talking about Postgres today, I would encourage you to take a look at it as one of the possible solutions. And it does has that special extension that can be used for geodata. Like you said, that you need to have this mapping function. You need to, as far as I understand, you need to know a current location of a truck, right? Where is it located? Where is it driving? So this is the extension that makes Postgres the geospatial database. It's not available in this many early access program yet because I've been working on this chapter right now. You can see like the manuscript. This is the draft of the manuscript. So this is what I've been writing right now. And but it does have it. I mean, for instance, in that chapter, I will show how to use a data set from the OpenStreetMap. You load it, and then again, a bunch of queries that educate you how to use the data set you can display. I live in Florida, that's why I just downloaded the data set for Florida, and then we are going to experiment with that data, with the maps. Check it out. When it comes, let's say, to an actual deployment environment, it's up to you. Once you select the stack, if you do the POC with Postgres, you don't even probably need to buy any machine, at least in the beginning. Even if you take these options such as Neon or Superbase, let me check. Do they have any? Do they support Neon Postgres? Yeah, Neon supports Postgres extension, so it's enabled. Try it Neon. So which means that you can just sign up, create your account, and start playing with your actual data. Do the POC. It will, especially in the beginning, it will cost you almost nothing, right? Definitely down below $100. Then once you start scaling, you will find out the approach. But at least you might stick to Neon. If it becomes for any reason once if you if your application service is getting traction, if you need just to migrate somewhere, as long as your application is already built for Postgres, you can stay on Neon. You can migrate to another solution. Same I think for the Superbase. Let's do Superbase Postgres. All of them have to support. Yeah, I mean, this is one of the top Postgres extensions. So take a look at Postgres. And the easiest way for you might be to start either you just on your developer machine. This is what I do with Docker or whatever, or just Neon or Superbase.
What about, okay, so that's fine there. I get that part there. I think the harder part is the map. Like for each, okay, so this is what I calculated out here, and this is why the pricing is so high, is because Google Maps charges per 1,000. It's like $7 per 1,000 map calls to the API. And I thought about how many map calls I would make on this website here, because it does require the user to use maps. You're probably calling
I got it. Yeah, this goes actually, I think,
hundreds per day per user.
Yeah, this goes beyond I think the today's topic, and I'm not an expert. Probably some of the folks who are.
Yeah, okay.
If I may come in.
Yeah.
Yeah, I've mostly built web-based applications for upwards of 15, 20 years now. Even though I've worked for large corporations, mostly in Canada here, who use AWS, but I do not suggest for small companies to start with AWS or start thinking about all those like microservices and all of that. Only big companies do that. So I would suggest, like he said, you can use Neon and these backend databases, but you should consider VPSs, virtual private servers. Most hosting supports it. These VPSs usually have a fixed price, usually under $100 you get, but it's a fixed price per month. You won't get a surprise bill that will suddenly kill you if you're on the cloud, because things like people like Amazon, they have all sorts of wording in the way they put their pricing. It will look cheap, but you wouldn't know they're also charging compute, and you might get a surprise bill. But with a VPS, instead of like a physical server, with a VPS, you can start with a certain VPS size. Then you could simply tell your host, I want to upgrade this VPS. So you could keep upgrading. Then when you are successful, you could now get in more experienced software engineers to help you scale. But don't go wasting 30,000. Believe me, you do not need to do that. You don't even have to do that. I've built a lot of stuff that handled heavy traffic on virtual private servers. These VPSs are just like virtualized machines that are, you are familiar with VPSs, right?
Mm-hmm.
Yeah. Somewhat.
Okay. So, yeah, but it's like they are so straightforward. You can just get somebody experienced. Everybody knows an experienced friend to help you set it up. They usually click, click, click. What's your platform developed on? What's the environment? What is it developed on?
Bash, we are deviating from the topic. So maybe you can take this offline, exchange emails, and help one another. Okay. Nikhil had a question hand raised for the longest time.
Oh, sorry.
No, that's okay. So connect on LinkedIn and continue after this is communities for this. But it's going to end up on YouTube and it's not relevant.
Yeah, my Gmail is there and my YouTube is.
Cool.
My LinkedIn, I'll post my LinkedIn there too.
Your question, Nikhil, you're muted.
Thanks, Daniel. Corey, I just shared a link with you on the VPS thing that Bash was mentioning. This might help you on deciding which approach to take for your hosting and the VPS thing too. I had a question even before the final question here. Yeah, so thanks for your talk and again. I just had a question about the full text search versus the PGVector. Right? So where would you suggest using a PGVector versus a full text search? I mean, I understand the semantic search aspect of it, which is pretty obvious in terms of embedding model and stuff. But would you suggest using PGVector when there's a lot of unstructured data or a lot of high cardinality in the data, and not use a full text search for that? Like, are there any performance considerations that between the two options?
Yeah, I mean, my point is that no, I don't want to. I don't want to discourage from using the full text search. My only point was that for me, full text search is in the core Postgres. You don't need to install the PGVector extension. It's there. There are special functions and operators for the full text search. There are special index types that will make the search efficient. And generally, if that's all you need, let's say you just have the data, you have the descriptions for your movies, and the user types in some phrase or keywords. If you just want to find something by those keywords, just use the full text search. If let's say you want to provide a little bit different experience, like that semantic search, when people write something that should be related, but you don't quite have that description of your product in the database, that's why you can install PGVector, you can generate embeddings, because for the embeddings it still kind of consumes space, right? Every embedding is, even if you take my example, every movie embedding had 1024 dimensions, and every item in that 1024 dimensional array is double, 8 bytes, like 8 times 100 1024. It's like 8 kilobyte, just for one embedding for one movie, 8 kilobytes at least, right? And it can go up. So that's why, and the vector similarity search, it's not a quite cheap operation, right? You need to run it. I think that full text search should be more compact, more efficient. So my point is that select the tool that does that does the job, the best way possible. Like don't try to over-engineer. Just pick what's best right now.
Yeah, would you then suggest like a full text search and then start falling back to a like a PGVector thing? Like if the full text search does its job, then you don't even go to the like an if else thing.
You can do both, like in the same table,
Yeah.
and even in that table, you can have those. In the full text search, you need to you take your text like descriptions of your movies, and you generate lexems, and lexem is like the language like representation of the text, and you can generate those lexems on the fly. But for every request, or you can just generate them once and then you can store them in the table. So in the same table, you can have when you're running your POC, proof of concept, you can have in the table, let's say, embeddings. You can have lexems generated for the same description of your product or whatever, and then you can compare the results and pick whatever you need.
Interesting. Okay, that's thanks for the example.
Any other questions? Sorry, we went a little bit longer, but turned out to be a good topic and a good turnover. And anybody else?
Still a hand up, but maybe that was from before. Bash, is there another question? I think that was from before.
That's from before, probably. I really like his name. I spent days in Bash.
Born again.
So okay. So I was using the time during Q&A to paste some names I see here in the chat for the book raffle because only 10 of you did it. So let me share the screen this time for real. Can you see my screen?
Yeah.
Am I sharing?
Yes.
So these are the people that did. So these are the people that did, and then I pasted some of you, assuming you want a free title. So this is not limited to the book. So my suggestion would be use the 50% off coupon for this book. Mining rarely has 50% off, so this is really a treat for this particular book. And then if you win, choose anything else for free. So good luck to you. No, not here. Here. Jonathan, congrats. I would need your email pasted in the chat so I can introduce you to nice folks for Manning. So that
sure
would be.
He's still here. Do we still have Jonathan? Looking at the list.
I saw his name. I saw his name in the screen, like he was. Okay, so Jonathan, if you're not there, I will do once again. I pasted his name. Jonathan, are you there? No. So let's do another spin. Thank you. That was a good catch. So I removed him. So you have a chance again. So sorry, Jonathan. You have to be present here. Michael, are you with us?
Yeah, I see Michael.
Michael, so okay, congrats on winning anything digital from Manning. Paste your email. I need your email so I can send the introduction. Give us the email that you use when you purchase Manning products online. So it's the same dashboard. So that's from me. Is there any closing thoughts? Anything else? So nothing. I hope to see you in 10 days. It's going to be Googler Dan Dobrin talking about A2A agent protocol and layer underneath MCP. And then Google just announced ADK support in Java. He's a Java developer, so you no longer have to be Python developer to use Agent Development Kit. So, and then I hope to see you for another mining presentation in July. And hit me up with any ideas, anything you want to learn that you think we did not cover in the past, or you want to present. So, Denis, I really appreciate this. You were not easy to catch, but I owe you. This was amazing.
Thanks a lot, Daniel. Yeah, thanks for having me, because I used to present a lot before I started writing the book, but right now I just kind of closed that chapter of my professional career. But that was that good moment from my kind of past life when I finally could jump on a Zoom call and talk about something I'm passionate about. Hopefully, yeah, like this time it was a little bit chaotic for me because I didn't have, unfortunately, too much time to prepare. But who knows? Like probably sometime in the future we will meet again, and I will come, with more hands-on, more demos, if you folks are interested. All right, thanks a lot.
It was great. Love the demo. It was amazing. Thank you
very much.
Thank you.
You.
Bye-bye, everyone.